All right, everyone. We are going to begin kind of the second half, I would say. We're in the middle, but working towards the second half of Unit 2, all right? Really just trying to understand what a tangent line is, what a derivative is, what's differentiation, and now we start getting to some of the good stuff that will really help us. I don't know. My name today is Tangent. I don't know. I don't really think that would apply to me. A lot of times when someone asks me like, "Oh, you look kind of tan," I'm like, "No, more so just like windburn, if anything." But sometimes it might look that way. Now, you know what I'm talking about. Um, let's look at how to calculate derivatives of familiar functions. We've already done a lot of these. We might not realize it. So basic differentiation rules, okay? The first one is the constant rule. The derivative of a constant function is zero. In other words, the derivative with respect to x of any function, if it's constant, it's c, right? Because a constant function has no slope, right? Here's a quick example. What's the derivative of 5? Notice this kind of new notation here. It's just saying, what's the change in the function called 5 with respect to x? How is 5 changing? Well, if the y values are always 5, then they never change, right? The derivative of a constant function is always 0, right? The special case of what we call the power rule. Let's first look at this special case because you already know what we mean. The derivative with respect to x of the function called x is 1. Remember how we said the slope of if this is a linear function called y equals x, the slope is always 1, right? And we've seen this before, like if I have a function that's linear, then its derivative or its slope will be constant, right? It's always that 1 degree of separation between a function and its derivative. And that's what's going to happen to us right here. The power rule. This is exciting. You will use this so much this year. Remember when we had to work out all these derivatives by hand? Let me grab this. Just today in class, we were looking at how do we find this derivative. The power rule will allow us to take this function and find its derivative without doing all of this work, right? The power rule is so useful. So all that it says is the derivative with respect to x of x to the nth power is n times x to the n minus 1. Now, it has to be differentiable, first of all. So we have to make sure there's no cusp or any sharp turns in that graph. For it to be differentiable at 0, it must be a number such that x to the n minus 1 is defined on an open interval containing 0. All right, we'll see if that happens to us. So here's what this means. The derivative with respect to x, right? This sort of new notation of x to the 5th, right, is, well, we're going to apply that power rule. In this case, I'm going to take n to be 5, and I'm going to write that 5 out front. Then I simply note that the derivative is always 1 degree less than the original, and that's where that minus 1 comes in. So what I can note is the answer is 5x to the 4th power, right? That's it. That's how we calculate the derivative of just this exponential function. Now, this one I'm going to rename x to the 3/4. And now I have to remember how some fractions work. The derivative of that function g of x with respect to x. Now, first of all, if I want to do this, I could say y is equal to 3x to the 4th. Just to get kind of fancy with our notation, If I took the derivative of both sides, do that. What's the derivative of that? What's the derivative of this? Okay. Now, the derivative with respect to x of y, I'm just going to combine as dy dx. It's the change in y versus the change in x. And that equals the derivative with respect to x of x to the 3/4, right? So this notation is very similar to, prime notation. They all kind of mean the same thing, first of all. Dy dx, I could interchange that with in that case, g prime of x. They really mean the same thing, right? What other notations could we use? I'm sure we'll see a bunch of other ones, right? If they're helpful. But all I'm saying is the derivative is, now I take that exponent 3/4 and I write it like that. Then I have to knock 3/4 down by 1, and that would become 3/4 minus 4/4, which is negative 1/4. And we're always going to write these with positive exponents. What that means is then, to make x to the negative 1/4 positive, I'm going to write it in the denominator. So I could do that. 3/4 x to the 1/4 power. That would be the answer for that one. Okay? And for C, right? What's the derivative of y equals 1 over x cubed, right? Well, I would first note by saying this is the same as y equals x to the negative third. It's easiest to rewrite things as exponents so that you can apply the power rule. Notice this was already an exponent. I rewrote the radical as an exponent. I rewrote this rational expression as an exponential, x to the negative third. Now what I can say is the derivative with respect to x, the change in y versus change in x, is negative 3, because the negative 3 goes out front, x to the negative 3 minus 1. Remember, you always knock it down 1, which would become negative 4, right? So the derivative of the function with respect to x is negative 3x to the negative 4th, or negative 3 over x to the 4th, right? And that's my answer, okay? Now, that would then come as no surprise if you were to look back at those, the ones that we started with. Does that make sense that the derivative is 6x? Because the derivative of a constant is 0. So I don't have to do anything with the 1. It's just 2 times 3 is 6x, and it's 1 degree lower. You could even, if you want to take a second to think about why this is this, you might want to change this to x plus 1 to the negative first power, right? Because that's really saying this. And then I can apply the power rule, right? If you want to think about that. Now, let's move on to the constant multiple rule, which we actually already brought up. The derivative with respect to x of a constant times a function is the constant times the derivative of that function. In other words, if I want to know the derivative of 2 times x to the 7th, it's really 2 times the derivative of x to the 7th, right? With respect to x. So what's the derivative of x to the 7th? Well, it's 7x to the 6th, right? So I'm just thinking about x to the 7th, and then I have that 2 out front, and that's why it becomes 14x to the 6th, right? So that derivative is 14x to the 6th. In this case, I'm going to rename this 3x to the negative second, right? So the derivative, or here, let me stick with their notation. G prime of x is 3 times the derivative with respect to x of whatever x to the negative second is, right? So that would become 3 times. Well, I take the negative 2 and I write it out front, negative 2. Then I take x to the negative second, I drop it down 1 to negative third, and that would become negative 6x to the negative third. or I will rename it negative 6 over x to the third, right? All right, does that make sense? Okay, let's try one more for this part. We are going to move on to some more just to get it out of the way. I'm going to rename this x to the 5/6 over 8, right? So f prime of x, notice I have f of x, so f prime of x is its derivative. It would be 1/8 times the derivative of, with respect to x, of x to the 5/6, which is 1/8 times 5/6 x to the negative 1/6. How did I get negative 1/6? Well, 5/6 goes out front. I have to knock it down 1. 5/6 minus 1 is 5/6 minus 6/6, which is negative 1/6. Then I'm just going to take the 1 times 5, put it here, the 8 times 6, put it here, move the negative exponent to a positive exponent, and it becomes 5 over 48, x to the 1/6. Okay? All right, those are good. Yeah, they take a little time, but they don't take as much time as they did when we were using the limit definition of a derivative. All right, here's a couple that we can try, and there's reasons why they're good or why they're different. First of all, this derivative, and here I'll throw in another one, y prime. Y prime is another way I can write that, right? Just prime notation. Y prime is 3/8 times the derivative with respect to x of x to the fourth, right? And what that becomes is 3/8 times, well, what's the derivative of x to the fourth? That would be by the power rule 4x to the third, right? So y prime is 12 over 8. 3 times 4 is 12. X to the third. And I should always simplify fractions. So divide by 4, that becomes 3 over 2. X to the third. All right. All right, let's keep rolling with these. What about this one? 1/8, or I guess it's y equals 3x to the fourth over 8. The first thing I should do here is raise them both to the fourth power. 3 to the fourth is 81. And so it just looks better this way. 81x to the fourth over 8. Then it's easy then to see that it's really just 81 over 8 times the derivative with respect to x of x to the fourth, which is 4x to the third, right? And what that becomes is, oh man, if I had my calculator, 324 over 8, or you know what? These cancel to 1 over 2, so that might be an easy way to cancel them. The 4 on top, the 8 on the bottom. So I now get 81 over 2 x to the third, right? If you can see how that one works. Okay, so then this one, 9 over 7x squared. Essentially, 9 over 7 doesn't really play a part, 9 over 7. But it does help if you rewrite this as 9/7 x to the negative second before I go and apply the power rule. So I'll write that down. Times the derivative with respect to x of x to the negative second. Okay? So y prime equals 9/7. What's the derivative of x to the negative second? You put the 2 out front according to the power rule, -2. You drop it down by 1, so that's -3. And then we simply combine. That's -18 over 7. X to the -3 can go like that and go on the bottom. Right? -18 over 7x to the third. Okay? Finally, the best way to start this one, everyone, 49x squared. Okay? The best way to start that one is by getting rid of the parentheses and really just kind of working with this. 9 over 49x squared. Again, a better way of calling that, it's almost like we just have to set the table, right? I'm just rewriting y so that it's easiest to apply the power rule. Then y prime will become 9 over 49 times the derivative with respect to x of x to the negative second. So what's the derivative of x to the negative second? Well, that would become, so keep the 9 over 49, negative 2, because that negative 2 goes out front, x to the negative third, right? Again, we saw that in this one. But since that 7 was in parentheses, it worked out slightly differently. That becomes negative 18 over 49 x to the third, right? I'm going to put that positive exponent and move it to the denominator. All right, we will come back to these, and there's no difference, but the sum and difference rules are just ways that we break apart derivatives, sort of like we broke apart limits into just, 2 or 3 or 4 sums or differences. We'll come back to those tomorrow and finish with some other topics. By the way, what is the derivative of Amazon? All right, you'll have to watch the Ed puzzle.